Hi everybody, Mr. Wada here, and today we're going to be going over how to name ionic compounds. So we've spent the last couple weeks going over how do we draw a chemical. So I give you a formula, how do I figure out how you put those pieces together. Now we need to learn what to call those things so that we can then move into how they react and things like that. So part one's ionic compounds. The second part is going to be molecular or covalent compounds. So to start, we need to know what ions are if we're going to go over ionic compounds. And ions are atoms that have charges, basically. And there is a different pattern for the metals and nonmetals. So if you look at the periodic table, all of the elements from the transition metals in the middle to the left are metals. And all of those make positive charges. They give away electrons. Basically, the charge that they get is going to match the number of valence electrons they get. So group 1, elements in there have one valence electron. They can give away one negative charge. And if you subtract the negative number, it's like adding it, right? Like if you owed somebody $3, that means relative to them, you're minus $3. If someone subtracts your debt, that's minus negative $3. That's the same as you gaining $3, right? Two negatives combined like that make a positive. Anyways, so metals will make positive charges, and the nonmetals, those are on the top right of the periodic table, are going to end up making negative charges. And their charge is going to be found basically by taking 8 minus their valence electrons. So group 5, that's 8 minus 5 should be 3. Group 6, 8 minus 6 should be negative 2. Group 7, 8 minus 7 should be negative 1. And then group 8 would be 0. Some elements kind of break this rule to a degree because the transition metals are weird. They have the ability to make different charges. Sometimes those are called oxidation states. And an example of that is iron, which is 2 and 3, which is based off of the plus 2 and the plus 3. So, monatomic ions. Mono means one, atomic means of an atom. So, ions of one atom. Those are pretty simple. You've got metals and nonmetals, and you'll notice that the metals there, like sodium, vanadium, copper, they keep their name the normal way. The negative ones, those are the nonmetals, end in "ide" now, which we'll get to in a bit. So oxidation states, same thing as their charges basically. They're going to have that pattern like I said. And if you notice, this is basically the number of bonds pattern. Again, group 1 made 1 bond, group 2 made 2 bonds, group 3 made 3 bonds, group 4 made 4 bonds, group 5 made 3 bonds, 6 made 2 bonds, 7 made 1 bond, and group 8 made none. So this matches that pattern. And then the ones down there make multiple charges, and the reason for why is pretty complicated, but it has to do with the way that electrons are and all of the different rings that they have. If you looked at the Bohr diagrams that we made with all those rings, you would see that electrons can bounce around from ring to ring sometimes there. So because of that, their charges are a little weird. Okay, so we have some practice examples here now, and we've got this labeled table again here. And the goal is to figure out what the oxidation states are for those. So basically, take a look at the element and match it up with its charge. If you need to take a second to do that, pause the video here, and then once you've gone through the examples, come back because I'm going to share the answers now. So, the first one we've got is sodium and chlorine. Sodium is element number 11. It's down here. It's in group 1, and it has a charge of plus 1. Chlorine, over here, negative 1. Calcium, over here, plus 2. Oxygen is over here, minus 2. Calcium again is plus 2, it's right here. And fluorines should both right here have a negative 1. And finally, we've got hydrogen, which is +1. It's in group 1. And chlorine again, it's in group 7. So it'll be -1. Okay, so next up, we're going to be going over how to name the individual pieces. You may notice there's some Roman numerals there at the bottom. You're going to need to know how to count to 5 with Roman numerals. To name metal ions, it's very simple. You just take the name of the metal and then add the word ion. So for example, sodium is sodium ion. Magnesium is magnesium ion. If the metal ion has more than one possible charge, like the iron example, all you do is you say metal Roman numeral ion. So you would add the Roman numeral for the charge in the bracket afterwards. So iron 2 is called iron 2 ion because it has a +2 charge. Iron 3 is the +3, so it's called iron 3 ion. For some examples here, we've got calcium, which is always +2, so you don't need to tell people what charge it has because they would know what charge it will have based on its group. You have to list the number for the other ones, though, like titanium 3, because there is the possibility that you could give the wrong one. So, for example, say you went online to Flynn Scientific and you were like, I want to do a flame test, or I want to do something, some kind of reaction, and you have to get a kind of metal. If there's more than one kind of it, more than one oxidation for it, more than one kind of charge, you could buy the wrong thing, which would be problematic because now it's not going to react the same way. So you would need to know exactly which version it is. So you would do that by number, sort of like comics go by number. If you wanted episode 7 in a TV show, you can't just say, oh, I want to watch this show. You would have to, by number, reference which one it is. Same idea here. So anyways, for the ones that have the oxidation number in there, you've got titanium 3 ion and cobalt 2 ion. So again, take a second, pause the video if you need to so you can get the answers. And if you're watching at this point, I'm going to assume that you're good to get the answers now. So you've got iron 2, which is also known as iron 2 ion, cobalt 1, because it's got a charge of +1 there, cobalt 1 ion, and iron 3, which is iron 3 ion. You can do the same thing here, again, only this time add the charges. In this case, you would get chromium +3, so that's Cr3+. Mercury is actually Hg, so that'd be Hg2+. And then the one on the bottom is actually pretty difficult because you would have two of them together, Hg2, 2+. But that's, again, different formula. All right, so now we're on to the negative ones. Basically, you take the name of the element, remove the last part, and you replace it with "ide." For example, you have sodium chloride, which is table salt. In your toothpaste, you have fluoride. It's fluor, the root of fluorine, and then "ide," the ending. So, try it with these. First one you've already got. Okay, at this point I'm assuming you're listening in for the answers. So F- is fluorine, ends in "ide," which makes it fluoride. Nitrogen, nitro is the root, "ide" is the ending, so you get nitride. Oxygen, O2-, oxide, and iodine is iodide. The last thing we're doing today is naming compounds. And there are a couple of different kinds of compounds for ionic ones. You've got binary and polyatomic. Poly means multiple. Binary means there's two options. So that means binary is two types of atoms. To name these is actually really easy. You take the name of the metal, and then you follow it with the nonmetal. Metal ions are called cations, and the negative ions are called anions. If you want a really corny way to remember that, I positively love cats. Positive, cat, cation, Cations are positive. Okay, let's give these ones a try. So we have calcium and chlorine, magnesium and sulfur, and then zinc and oxygen. So for all three of these examples, the first element is a metal, and the second one is a nonmetal. When you're naming these, you go metal, and then the name of the nonmetal with "ide." So for the first one, we've got calcium and chlorine, so you would have calcium chloride. For the second one, you have magnesium. Magnesium and sulfur would make magnesium sulfide. And the last one, zinc and oxygen, would make zinc oxide. If you notice, again, same pattern for all these. It's metal, it's the first one, and then the non-metal with "ide" at the end.